So Unit 1, guys, our first unit is going to be pretty quick. We'll be done by Friday next week. We'll take our first test actually then. Unit 1 is just reviewing linear functions. You started there, well, you got there pretty quick in Algebra 1. You probably started there in Algebra 2. We'll start here again. Why do we keep repeating it? Well, it's foundational. I mean, it's the easiest way to communicate a lot of the ideas we're going to be talking about all year long, like slope, intercepts, graphs, functions, tables. It's a really simple equation to do that kind of stuff with. And also, it's extremely useful. You know, I mean, even in calculus, we start with linears again, but we're doing something different with them. We're not just learning about them, we're actually using them for something, but we actually start there also. So it's extremely useful. So what are we going to do in this unit? Other than, well, today, what are we going to do? Today we're going to focus on, make sure you guys know what a linear function is. You should be able to tell me what the slope is of a linear function, no matter how I present it to you. I could present a linear function to you in three ways. I can present it to you as an equation, I can present it to you as a table of data, or I can present it to you as a graph. In all three ways, you should be able to tell me what the slope is. Okay? So that's what we're going to do. Also, same thing for the y-intercept. You should be able to look at any of those three representations and tell me what the y-intercept is. And then also, this is moving into some calculus-y kind of stuff. In calculus, we talk about slope a lot, and because slope helps you know something about a function, whether it's increasing, decreasing, or neither. So we'll talk about how you can tell if a function is increasing, decreasing, neither. You might already know that as well. So most of this stuff is just going to be review, but it's worth reviewing. So let's take a look at part A. What is a linear function? Are there any blanks for that one?
Yeah.
Okay, I'll wait a second for you. So there's all kinds of functions out there. Function is basically just something where if you plug one number into it, you can find the other number that, like, you get next, you know the y that goes with it. That's what a function is. You plug something in, you get something out. There's all kinds of them. Quadratic is a function, logs are a function, exponentials are a function. But we're talking about linear today. So what's a linear function? A linear function can be thought of in these three ways. First, I'm going to start actually with number 2. When you graph a linear function, it's a straight line. And what that means is that no matter where you pick for that line, like if you were to go from here to here or from here to here, the slope will always be the same. You guys remember slope is rise over run, right? So no matter what 2 points you pick, you're always going to get the same rise over run. Even if you did a really big one, you're going to get the same rise over run, just the numbers will be bigger, but when you reduce it, it's going to be the same thing. So that's the third characteristic. Their slope never changes, it's always the same. So that's a linear function characteristic. Other functions like quadratics, they have changing slopes. Their slope is not always the same. They get steeper and steeper, and that's why they start to bend. That's why they're curved and not straight. And calculus is all about, one of the big topics there is finding the slope of a bending function. Okay, but I digress. We're talking about linear here. So as an equation, they can come in different forms, but this is the most common and the most useful, y equals mx plus b. Okay, so that's what a linear function is. Let's talk a little more. More specifically, we're going to be learning about rates of change today. So go and find your blanks there and fill those in. rate of change. Okay. Now, rate of change, you know, when you're looking at a function, you have two variables, right? We talked about like x and y, and they're changing at the same time, you know? So like when you have y equals x squared, if you plug in 1, you get 1. If you plug in 2, you get 4, right? So as the x changes, so does the y. Rate of change just means how fast are they changing. So if you change the x this much, how much will that change the y? Okay. In other words, the rate of change is the ratio, the comparison of in a fraction, the comparison of the change in y and the change in x. So rate of change is just fancy words for slope, because that's what slope is, right? Isn't slope y2 minus y1 over x2 minus x1? You remember that? Well, y2 minus y1, that tells you how much the y has changed, right? If y goes from 3 to 5, how much did the y change? 2, right? So that's the change in y. And then x2 minus x1, if you're going from like 6 to 8, right? That's also 2, right? So that would be a ratio of 2 over 2, which is 1. So slope, the fancy word for that is rate of change. Now, mathematicians and scientists and physics and stuff like that, they don't like to write rate of change repeatedly. So we use this little symbol here, the triangle. It's called delta, and it means the change in. So delta y means the change in y. So y2 minus y1, if it was like we said, what did I say? It was like 3 and 5. Then delta y would be 2, right? Because it just changed by 2. That's all it is. So that's kind of a new symbol for you probably. But all it means is rise over run. Why? Because when you're talking about y, what axis does that go on? Does it go on the vertical or the horizontal? Vertical. So if y is going from 3 to 5, what did it do? It went up. It rose, right? And whenever your x is changing, like I said, what, 6 to 8, what are you doing? You're moving right one, but we can say, we call it running one. So you're running one and you're right. So it's rise and run. So what we have here is basically a list of synonyms. All these things mean the same thing. Rate of change means slope, which we represent with the letter m, and can be calculated with 2 points using this formula, which can be shorthand written with the deltas, and it's what we call rise over run. It's all the same stuff, just represented differently. So that's what slope is. It's just basically how much the x and y variables are changing. Now, let's talk about increasing versus decreasing. That's weird. Okay. Okay, so, let's say I have a graph, and I've got a point right here. And I'm gonna go to the right, because I always like to go to the right. In math, we usually think of going from left to right, kind of like when we read a book. So as I go to the right, let's say my next point ends up here. So I had to go up, correct? So let's say this y value here was 2, and this y value here was 5. What do you notice about my second y value compared to this one? It's bigger. So if I did y2 minus y1, what would I get? 3. And what kind of 3 is that? Positive 3, because it went up, right? So when your second y value is higher than your first y value, then you end up with a positive, and that causes your function to go up. Exactly. So now let's draw that out. So I'll draw another graph here. So suppose I had a dot here, but as I go to the right, the next point's down here. Well, let's say this was 1 and this is like -3. Well, if I do y2, my second y is -3, minus my first y value, which is 1, I get a negative. It went down, decreased. So when your second y value is smaller than your first y value, when you subtract them, you're going to get a negative amount, and that's because the function is decreasing. So if the y values are increasing from left to right, then it's increasing, and your slope will be positive. If the y values are decreasing from left to right, then it's going to be sloping downwards, and the slope is negative. Now, if your y values don't change, like here, if I run to the right and I didn't go up at all, then my slope is 0, right? Because y2 minus y1 would be 0. They're the same. So in that case, the slope is 0. That's called a constant function, right? So that's just what increasing and decreasing and constant means. And then finally, before we get to some actual math practice, let's talk about the y-intercept here. The y-intercept, you guys have any blanks for that one? No? Okay. So I think the easiest way to understand it is the third one right here. It's the place where your graph crosses the y-axis. Okay? That's your y-intercept. Now, when you're at the y-axis, let's say that I'm up 1 here. What's the x value there? 0. Anytime you're on the y-axis, the x value is 0. So since it's the place where it crosses the y-axis, you can also think of it as the place where x equals 0. Okay? And that's helpful because if you ever have an equation, if you want to find your y-intercept on any function, you can just plug 0 in for x, and what you get for y would be where it touches the y-axis. All right. Finally, it's the initial value. You know, in a story problem, for instance, I have $30 and I spend $2 a day. Okay? Well, what's my starting amount? 30. That would actually be your y-intercept because I'm changing how much I have every day. And so at 0 days, how much money do I have? 30. So that's my starting amount. So your initial amount starts at 0. It's your initial amount. So when you're talking story problems, it's your starting amount. All right. So that's y-intercept. Just some quick review. Let's go ahead and jump into some problems. This is the one that's on your notes. I wish I had printed out all of the examples, but I didn't. So let's go ahead and we'll focus on this one here. The directions ask us to do 3 things. Let's read our directions first. It says, for each linear function below, determine the value of the y-intercept, so we want to find that. Then we want to find the slope, and then they want us to decide if it's an increasing, decreasing, or constant function. Okay? So that's our goal. We're going to do those 3 things for all of these problems. So 3 things. Let's go ahead and give it a shot. Okay, so this is the first one. You guys see that on your notes? Okay, so let's start off with the y-intercept. What is it? -2. Now I'm going to write it as a point, but what am I going to put for x? Good. So the x value would be 0, but the y value is negative. All right, now we got to do slope. Okay, so to do slope, you want to pick 2 points on your graph. Does it matter what 2 points you pick? No, because we're trying to find slope, right? And I told you that no matter where you're at on your line, the slope's always the same for a linear function. So it doesn't matter what 2 points you pick. But you want to pick 2 points that you can find the coordinates of. So I'm gonna pick this one, right? Because I can find the numbers for that. You wouldn't want to pick something like here, right? Because I don't know exactly what the x value is there, correct? So pick something where you can actually get some good numbers. And we'll use this one too. Let's use the y-intercept. Why not? I want you guys to write the points for those really quick for me. Go ahead and write the points out. That's something sometimes we need to practice a little bit. Remember, x comes first, y comes second. There's 2 ways you guys can do this. I'm going to show you the way that maybe you're comfortable with, but then I want to show you guys a new way to do this a little bit faster, but it may be uncomfortable for you, okay? So the way that you're probably comfortable with is just to think of one set of these as x1, y1, and the other set is x2, y2, and you can just do your formula, okay? So that would be y2 minus y1. Oh, this is a -2, my bad. y2 minus y1 over x2 minus x1. And what would that be on the top? The top would be -4. The bottom would be -1. And what's negative 4 divided by negative 1? 4. So my slope is 4. Okay? Now that I don't know, that way might be comfortable for you because you're just using the formula. However, I want to show you guys another way to do this because you don't really need to use the formula. You can use those same 2 points. And I'd like you guys to do this as well. If you start at this point, and it doesn't really matter what point you start on, I like to start on the one on the left personally. So I'm going to start with this point here. If I start here and I want to get here, tell me the directions I would have to go. I have to go to the right one. So I'm going to put an arrow there because I went to the right. And then what would I have to do? I'd have to go up 4. Now, 1 and 4, right? That's how long those sides of that right triangle are. Now let's remember the directions though. This was right 1. Is that a positive or a negative? Positive. When you go to the right, that's a positive. So I'm going to put a plus there. And I went up 4. That's also a positive, right? This is my rise, isn't it? This is my run. So rise over run, 4 over 1 is 4. It's a lot quicker, in my opinion, just to kind of go, got my answer, as opposed to having to plug in numbers to a formula and maybe screw up on the negatives or something like that. All right. Anyway, all that being said, is this function increasing, decreasing, or neither? Why is it increasing? That's the answer I want in here. Now, some of you guys are thinking geometrically, like, well, you could say this is right. You could, here's what's kind of incomplete. You said, well, it's going up. It's like, well, what if I'm going this way? Now it's going down, right? So what you'd have to say is, oh, as I go to the right, it's going up. You could say that, because you have to include both directions. But the easiest answer is just because the slope's positive. So I'm going to put here, since the slope's positive. Okay. Let's do the next one here. Can I erase stuff? Okay. Okay. So this time I'll let you guys kind of do a little bit of the work. So go ahead and find the Y-intercept first. I'll call on you in just a second to share out your answer. So Ruben, what do you think the Y-intercept is, sir?
X is 0 and Y is 1.
Good. There's that. Nice job. All right, now for this next one, I want you guys to pick 2 points and then label them if you want to. You don't have to label them, but when I call on you, you're going to have to tell me the numbers so I know where to put the dots. So go ahead and pick 2 dots that you want to use to find your slope. All right. I'm forgetting who's Ricardo. Hi, Ricardo. What 2 points did you use?
I use 0 and 1.
Okay, so the Y-intercept. That works.
And I use 2 and 0.
2, 0. So this one?
Yes.
Okay. Now, just so you guys know, you could have used any of these other points as well. You had a bunch of options. Any 2 of those would have worked. All right, so now I'm going to let you guys find the slope however you want to. You could do the method I showed you, or you can do the formula. But go ahead and I'll give you a second. Isaac, what did you get for your slope? That is correct. All right, so doing it just geometrically without the formula, I like to start on the one on the left. Which way would I go? Down 1, which means it's a what? a -1, and then I would have to go right 2, which means it's a +2. And which one's my rise? Which is actually not a rise now, right? It's a drop, but we'll call it rise. And that's my run. So we have -1/2. And this question comes up a lot. I had one student in my last block get this. Why? Because she started on the right, which is fine. In that case, you'd have to go left and up, right? But these are actually the same thing. Doesn't matter where the negative is. So usually we don't even put the negative on the top or the bottom. We just put it in front of the whole fraction, just so you guys know.
So
I think so. And since you didn't, I'm not sure if you know which one goes on top and which one goes on bottom. So you got to be careful with that. Because sometimes the most common mistake people make is they forget rise and run, which one goes on top and bottom, and they flip it a lot. All right. Yes. All right. So Dylan Smith, he's the one that's not here, right? Let's do, bless you. Let's do Giovanni. Giovanni Perez. What is this, increasing, decreasing, or constant? You're Giovanni Perez, because there's another Giovanni over here, isn't there? Right? Okay. So Perez. So it's decreasing. And why is it decreasing? You got it. All right. Which means we can actually write this as an equation. I saw some of you guys doing that already. Remember this? What does the M represent?
So,
And this is?
Y-intercept.
So what's the equation of this line? It's 1, yeah. There's the equation, right? That's the fun one. I saw some of you guys doing that. I think that's cool. You didn't have to. All right. Let's do one more. It's not on your notes, though. In this case, the people who use the formula might have an advantage, because trying to do the thing I showed you on this one could be a little weird. Go ahead and try this one here on the left. I'll pick the 2 points for you. Let's just say we're going to use this point and this point. So find all 3 for me. Tell me, is it what's the y-intercept, what's the slope, and is it increasing, decreasing, or constant? Carlos, what's our y-intercept? Kind of hard to tell from the seat. It's not on your paper. Okay. It's where it crosses the y-axis. Right there. Okay. Let's take a look at the slope. Giovanni Ramos, what did you get for the slope? It's 0. Why is it 0? Well, what's my run? 3. What's my rise? There isn't one. Anytime you have 0 on top of a fraction, it's 0. Now, if you did the formula, then it would be 0, 3, and 3, 3, and that would be 3 minus 3 over 3 minus 0, which is still the same thing. Okay. Therefore, we would say this is increasing, decreasing, or constant, Sophia. Constant. The y values don't change. They stay the same. So constant. All right, so we'll stop there with that. I want to talk about tables a little bit before we call it a day. So let's take a look at number 3. Now, I think on yours, for some reason, I didn't put the y values, so you guys will have to scribble those in there somewhere. Yes. What's that? Yeah. nobody's answer. I'm afraid. I'm gonna try one more. Nobody's answer. I'll try again. All right, guys. So when you have it in a table, probably the best way to go about it is with the formula once again. It's basically just, these are points, right? Can you see that? What's my y-intercept? Because why? Because the x is 0, right? Where x is 0, that's your y-intercept. Slope. You already got it? So what I'm going to do is I'm going to label these, right? This is an x value. I'll call it x1. This is a y value. I'll call this x2 and this y2. Notice I'm not going to use the 5 and negative 14. You don't need to. You just need 2 points, right? So we have y2 minus y1 over x2 minus x1. What happens with double negatives? So that's going to be 0 plus 1, which is 1. And so you're right, it's negative 3, and therefore it is a decreasing function. We're kind of, I don't know why I put an E on the end of decreasing. I think I'm feeling like an old English person. If you guys want to try for, we have 2 minutes of class left, and I'll put the answer up when the bell rings and you guys can check your work. But time crept up on us a little bit there. So I'll let you guys go ahead and try 4 if you want to. If you feel like you got to pack up because you got to get out of here, I understand, that's fine. But I'll put the answer up in about a minute or so.